Okay, great. So welcome back from the break. So what we're going to do now is we're going to solve for the optimal bundle. So what we've seen is that the extreme solutions, which we call the, what are they called? Corner solutions, that they give a utility of 0. And we have an internal point that gives utility that is greater than that, right? And so it is the case that there's some interior solution to this problem. Now the question is, how are we going to go about finding that? How many of you have covered the Lagrangian method of solving for utility maximization?
Is that within difference curves?
It's not within difference curves, it's where you have a penalty function. Have you seen that before? Okay. All right, well, I'm going to teach it to you. So I'll teach it to you, and then you'll do the traditional elimination method. And the reason why I'll teach it to you is because we just had this wonderful break, so our brains are nice and fresh, right? So we're just ready to write. Okay. Awesome. Okay, great. So what we want to do is we want to maximize this utility subject to this budget constraint here, right? And the way that this is implemented in the Lagrangian framework is to let's see if I want to do it that way. Okay. You probably have seen it done with the elimination where you solve for one of the functions using the budget constraint and then you go in that way.
Yeah.
Let's do that way first, and then we can do the other way. So that way you see something that's familiar, not freaking out. Oh my God, I don't understand anything that's happening in Professor Blair's class. Okay, so let's solve using the elimination method, right? The problem here is that we have utility as a function of two variables, right? However, we have a relationship between these two variables here through this budget constraint. So who can tell me what's the way that we should go about solving this problem? Don't be shy. Any takers?
You just want to substitute for either of the variables.
Uh-huh. So how might we go about doing that for us?
Setting them on different sides. So to find either x or either y.
Exactly. So of course it's exactly right. So what we're going to do is, so at the optimum, is Sandra going to spend all of her money or just some of her money? All of her money, right? Because she can always get more utility by buying more stuff. In this model, she doesn't have any utility over the money. It's like she has $1 million, and if she doesn't spend it, it just disappears. Right? The utility is only over dots and Xboxes. So at the equilibrium, so this is abbreviated EQ, the budget constraint will bind. And by bind, what I mean is that this inequality is going to be an equality. So what we're going to get, that implies that we're going to get 1,000x plus 500,000 y is going to be equal to what? 0, right? Now following Forrest's suggestion, what we can do is we can solve for x as a function of y, or y as a function of x. So let's solve for y as a function of x, right? So what we get here is that this is going to be a fun problem. 500,000 y is equal to 1 million minus what? 1,000 x. And so what is y equal to? Yeah. So what's 1 million divided by 500,000?
Or 2.
Yeah. So we're going to get 2 minus, what's 1,000 divided by 500,000?
500.
Yep. X. So this is what y is equal to, right? And let's call this equation star. What do we do next with equation star? So we know what y is the function of x. So what do we do next?
Substitute it into the first equation.
Exactly. So exactly what Anna is saying. So we now have utility of x, comma, y as a function of x, right? And that just gives us the utility as a function of just x. Because when we change the levels of x, we're also going to be changing the levels of y to make sure that the budget constraint is satisfied. Right? And when we do that, we're going to get what? X over 1,000 times what?
2 minus x over 500.
Say that again?
2 minus x over 500. Or whatever, 500.
To what power?
The 1/2?
Right? And we can solve this. How would we solve this for the maximum? Everyone's looking at me with-
We would put in 1,000 for x. Or, sorry,
So we have a function and we want to figure out where the maximum of the function is. What happens at the maximum of the function? What's the relationship between the derivative of the function and maximum?
So it's extrema.
yeah.
It's extremum, which means that the,
So maximum, the slope is 0.
exactly. Let's make one simplification and let's modify Sandra's utility function. So instead of it being y to the half, we'll make it a little simpler, just let it be y. Right? Because that will make our lives easier. So we're going to just simplify this, and I'll update the notes to reflect that. Because the whole point of this exercise is just to show that you're capable of not to give you a very technically difficult thing to do. All right. So now, at the equilibrium, we're going to get du dx is equal to what? 0, right? This is the extreme condition. So who can tell me what this derivative is? What is du dx? What is this derivative here? So we can expand this out. We get two terms. So the first term is going to be x over 500, right? When we multiply this out, we get x over 1,000 times 2. That's just x over 500, right? And then we're going to get minus x squared over 500,000. Everyone sees this? This is utility as a function. So everyone sees this one here. So when we take the derivative of the first term, what do we get?
1 over 500
We get 1 over 500.
minus x over 250. Or, yeah, I think so.
Minus x over
250,000.
Who followed this? If you followed this, raise your hand. If you didn't follow, raise your hand. There's no shame in not following. Okay, good. All right. Did you follow this step here? So what we did is we simplified the utility function. Instead of having a half, we just said let it just be like the power of 1. So that'll make the math easier. And to go from this line to this line, we multiply this by that, and we expand that. So we get this first term, x over 1,000 times 2, which gives us 2x over 1,000, which is the same as x over 500. Does that make sense? Okay. Then for the second term, we get x over 1,000 times x over 500,000. We multiply the two denominators, and we get 500,000. We multiply the numerators, and what we get is x squared. Does that make sense? And so we're going to have a function that looks something like this. If x is equal to 0, we get 0 minus 0 squared. And so utility function is going to be 0. If x, yeah, exactly. So we're going to have a function that looks something like this. It's going to be 0 here, and then if x is super large, then it's going to go to negative infinity, right? And so we're going to have a maximum somewhere in the middle of here. Now, this step here says that at the maximum, the derivative is going to be 0. Because what's the derivative to the left of this point? Is it positive or negative?
Positive.
It's positive, right? So the derivative is positive. What about here? It's negative. Because as we increase x, the value of the utility goes up. Goes up, goes up. But over here, as we increase x, the value of the utility goes down. Because we're getting to a corner here. We're moving to a situation, because the more of x we get, can we get more of x and more of y?
No.
No. The more of x we get, the less of y we get. Because y is going to be 2 minus x. So more x equals less y. This is the whole idea of scarcity. Okay. So to get from here to go to here, we then take the derivative of this function here. What's the derivative of x over 500? This 500 is just a free factor, so we just multiply that. And the derivative of x is just 1, right? If you have any function of x that's like x to the n, the derivative of x to the n with respect to x is just multiply it by n, and then you get x to the n minus 1. In this case here, n is just 1, and so we just get 1 times x to the 1 minus 1, which is 0. So that's this first term. For the second term, when we do the same analysis here, n is equal to 2. And so when we take the derivative, we get 2 times x to the 2 minus 1, which is the same thing as 2 times x to the 1, right? And then we cancel the 2 on top with the 500,000 here to just get 250,000. Who follows us up to this point? Everyone's going to great. And this is going to be equal to what? What are we saying is equal to? And why are we setting it equal to 0? Exactly. Okay, great. So what's the value of x going to be now? 500. So what we have is we then say x over 250,000 is equal to 1 over 500. So we'll just take this over to the other side. And so x is going to be equal to 250,000 divided by 500. Right? Everyone sees the step here? Yeah? Okay. We can cancel out 2 of the zeros. And then we can say that 5 goes into 25 times 5 times, right? And so then what we get is 500. Does everybody see this? 5 goes into 25 how many times? Does that make sense? So we have 500 underneath here. And so the way to think about this is we can just cancel out these 2 zeros here because it's like dividing by 100. And then what we get is 2500 divided by 5. Right? So we have 2,500 divided by 5, which is just going to be 500. Right? 500, 1,000, 1,500, 2,000, 2,500. So what's the optimal amount of x to get, of x boxes of Sandra to get? 500, okay. How do we now find the optimal number of yachts for Sandra to purchase?
Plug x back into the legs.
Exactly, remember this equation star here? This equation star gives us the relationship between y and x at the optimal point, right? And so what we can do is we can say that okay, I'll put this right here. So y star is going to be 2 minus 1 over 500 times x star, which is what's x star? 500, right? And so this is 2 minus 500 divided by 500 is what? 1. So this is what? Y star is 1. Everyone follow that? So what this tells us then is that our optimal bundle is going to be, and I'm going to write it down here. You may not be able to see that, so let me go over here. What's the optimal bundle? It's the 500. So this is x star and y star. And the stars basically say that these are special points because x and y are just general numbers of yachts. X could be 10, x could be 5, x could be 6, x could be 50, right? But what this star is saying is that these are the x's and the y's that maximize utility. Now let's go back to this exercise. What's the utility of 501? Well, given that we have taken off this half here. What is the utility of this optimal bundle here?
0.5.
And what you can do now is you can check to see if there are any other feasible bundles that will give us higher utility. Right? So we can take any point along this line or any point within this feasible set. And should any point within the set give you more or less utility?
Less.
Less. Every point. You can pick a, let's pick a, somebody throw out a point that satisfies this relationship. And let's test it. So you can think about it as a yacht share. Okay. Well, when you go home, you can play around with this and see what the relationships, and see that this in fact does hold, right? So do that as an exercise for yourself. There are a couple other things that I want to highlight.